What's up? Here's another packet tracer tutorial video for you. In the last video I went over a little bit on what we could do with this new network we added over here. Now, as you can see, I've already set it up kind of with what we're going to be doing in the next few videos. So I'm just going to go over that a little bit here. You can see I've broken down all of these hosts into different VLANs off of the access layer. So we've got a single VLAN hanging off of our 2 in switches and 2 VLANs off of every other switch in the access layer. Now you can also see I've assigned subnets already that we're going to be using. I said that we're going to just work with the 5.0.0.0 IP address with a /23 mask. So I've gone ahead and subnetted that down into usable subnets, and I decided to use the 5.0.1 up here as our, you can call it like what, our transport links, just our like point-to-point links between all of our distribution and core devices up here. And down at the bottom in the access layer, I've decided to give those 5.0.0. And these will all be using /28s, effectively giving us 14 usable hosts off each of these subnets. So we can just imagine that each office that's going to hang off of these switches are probably going to have, I don't know, between 8 and maybe 12 hosts. Can't go more than 14 though. Now, I've set a few goals that we're going to do for each of these devices. You can see first here is only management access. So we're going to have a management VLAN set up. It's actually going to be this one over here, VLAN 18 off of access switch 5. So the goal is to only allow these 2 hosts to be able to remotely access all of our devices. And you can see I've already given them the last octet of an IP address. So those are all going to fall under VLAN 18's subnet. And by having only these 2 hosts access these, we're going to be using access lists to restrict what hosts can access the devices. Now this subnet /28 is cutting it really close here. We're actually using 12 devices out of 14, so we really only have 2 more devices we could add in the future. Another thing, we're going to set our devices up to use an NTP server and a syslog server. I'm not going to set those up in this video, but we are going to do the configuration. We're actually not going to be able to set up NTP on any of these access layer switches because Packet Tracer does not allow it on the 2960s. We will be doing that on these in the later videos. Now we're going to do no CDP on trunks, so all of our trunk ports down here off the access layer are not going to be advertising CDP. This is just to cut down on needless network traffic, and we don't really need to use it. We're also going to have no negotiate on all ports, so none of our ports will be doing negotiation. And we're going to have port fast on access ports, which are all of our hosts down here. We're going to be running port fast as well as port security. And all of our unused ports will be in the shutdown state. This is just for added security. That's just an overview of how we're going to configure our devices here. Now, just a side note, you'll notice I threw in this server farm thing over here. Haven't completely decided if I'm going to throw anything else in here, but we know for sure one of these is going to be an NTP server. The other will be a syslog server. This will probably be our DHCP for our entire network here. And if you notice, we've got a lonely router here. This is actually going to be our call manager for all of our VoIPs. Now I'm going to break this configuration down into probably about 5 or 6 videos. This first one here, we're going to go through configuring the access layer. Second, we'll configure the distribution layer along with HSRP. We'll split the spanning tree process and all of that shit. And third video will probably be the core layer. We'll be configuring Ether channel with LACP for this link right here and PAGP for this link here. Now we're going to be using egrip as our routing protocol eventually. Obviously not in this video because we're not going to do any routing at the access layer. That's pretty much in a nutshell what we're going to do. I'm not going to waste any more time. We're going to go ahead and set up these access switches. So we're just going to hop on to access 1 here. And first thing I'm going to do, well, you can see I was looking at commands. Don't look at that. It's a head. First thing we're going to do is set up a host name. We're going to call this one access 1 to match its label I've already given it. Now, if we do a do show IP interface brief, we'll see the ports that we have up. We have Fast Ethernet 1 and 2 in the up state, as well as 23 and 24. Now, right now I can tell you that 23 and 24 are our trunks to the distribution layer, and 1 and 2 are our hosts. So what we're going to do is we're going to use the interface range command. We're going to set up Fast Ethernet 1 through 2 as our access ports. We're going to go ahead and do switchport mode access, just to hard code it to access mode. And we're going to use the command switchport access VLAN 10. VLAN 10 doesn't exist, so it's creating it. Alright, it's in the database. Cool. Now the other commands that we're going to do were no negotiate, so switchport no negotiate is the command we use for that. And we're going to set up port security. So command for this is switchport port security, and we've got 3 options here: MAC address, maximum, and violation. If you've read into port security, you should know what each of these mean. We're gonna just assign a maximum of, I like to use 5 with a phone and packet tracer because it likes to screw up. So right now we've got a maximum of 5 learned MAC addresses that this port will use before shutting itself down by default with the 6th unknown MAC address. We're also going to put in here switch port. We could use the violation command, however it's already default to shutdown. So if we wanted to change it to something other than that, we would, but right now I want to leave it the default. We'll do MAC address. Why is that unrecognized? Switch port security MAC address. And we're going to use sticky. This will let the port dynamically pull MAC addresses from plugged in devices. And the last one, we're just going to turn port security on. So for that we just do switch port security, and now it is enabled on Fast Ethernet 1 and 2. Now I know I'm missing another command here. Oh yes. I backed out of the interface. Interface range Fast Ethernet 0, 1 through 2. We're going to use the command spanning tree port fast. Now this is going to let spanning tree skip the needless states on these ports, like listening, learning, all that good shit. It's going to go straight to forwarding because these are not supposed to be switches connected off of these ports. They're in devices, so a loop should not occur. Am I leaving anything else out off of these interfaces? Don't think so. We'll just throw in a quick description of hosts. Now let's move on to interface range, Fast Ethernet 23 through 24. These are trunk ports. So we're going to do switch port mode trunk. And we're going to limit these down and limit what VLANs can pass over them. So we're going to do switch port trunk allowed VLAN 10. This is going to be the only VLAN off of this switch, so it's going to be the only VLAN we are going to allow over these trunks. We're also going to do switch port no negotiate and no CDP enable. Now if you're wondering why we didn't do no CDP enable off of the host ports, it's because we're going to be running IP phones. Now in Packet Tracer, the VoIPs will only work if we have CDP enabled off of those ports. In the real world you have a few alternatives, but CDP pretty much as a general rule, if you want to use VoIPs, you need it enabled. Alright. Did I leave anything else off on those trunks? We're not using port security, don't need port fast. Should be all we need to do for that. So we'll write that, and now we'll set up our remote access here. So let's go to line VTY 015, and we're going to throw in login local because we're going to set up a username and password here in a minute. And we're going to do transport input. We'll use all. Now this is not ideal. Usually you'll want to use only SSH because it's secure. But I want to do all because you can't, in Packet Tracer you can't use DNS with SSH. And it's a pain in my ass. So I'm going to just use Telnet. It's a lot easier, quicker commands. Now for this, we need to do an access list if we're going to limit it down. So let's do IP access list standard, and we can either give it a name or a number. We're going to give it the name management. So here we're in the ACL. You can see we've got our ACL commands here, deny, permit, whatever. We're going to do the command permit and an IP address. Now let's look at our management VLANs subnet. We're going to do 5.0.0.112, and we're going to have to use a wildcard mask, which it's a /28 subnet, so what's going to be the subnet mask could be a 240. So the inverse of that will be 00015. Enter. So with this statement, we're telling this access list to only permit hosts that fall in the 112 network with a /28. Now let's go back into our line VTY and do access class management. I did name it management, right? Yes. Alright, access class management in and out. So now on the VTY lines, it will not accept a connection from anyone that is not in this subnet. So that's how we limit our management shit down. Really don't know what I'm talking about. Don't listen to me. Okay, so up next, we configure the VTY line for management. We could have put logging synchronous in there, but fuck it for now. So if you're going to be using a management VLAN, you're going to have an interface VLAN for that. So I'm going to do interface VLAN. We're just going to give it 18, because just to keep it, VLAN 18 is going to be our management VLAN, so we'll just keep it at that. You need to assign the interface VLAN an IP address, which I've already designated here. It's going to be .117 under the 112 networks. So 5.0.0.117 with a subnet mask of 255.255.255.240, I believe is the /28. And no shut that. Now this is actually going to be shut down until we put VLAN 18 on the switch. So you do VLAN 18, and as you can see, interface VLAN 18's changed state to up. We're going to give it a name of management, abbreviated. So now we've got that set up. Now another step, if you're going to be running management, you're going to have to define an IP default gateway. Because switches are layer 2, they're not going to know where to send traffic received. So what will essentially end up happening if we don't define a default gateway is we'll try to access this switch from PC13. Eventually it's going to hit our distribution layer and get routed over to this switch. And it's going to receive that traffic just fine, but it being a switch and being dumb to anything layer 3, it's not going to know where to forward that back. So your request for management is just going to be dropped there unless you specify a default gateway, which in this case we're going to do the default gateway of the management VLAN, which is going to be 113. Which reminds me, I need to change this. That can't be 113. But that's a side note. My bad. Alright, back on here, IP default gateway 5.0.0.113 will be where it forwards all of the traffic. Okay, so we can't do NTP server. We can do a syslog server. So what we're going to do here, the command logging and the IP address of our syslog server, which is going to be 500.131. Eventually we'll set up a server in the little server cluster over there to be our syslog server at this address. Now we're also going to use the command logging trap. Now we only have one option in Packet Tracer, and that's debugging. This kind of limits what the which messages it will actually send to the syslog server, and debugging is the lowest level, level 7. So anything that severity and above, so it's going to output all messages. That's the default here in Packet Tracer, but in the real world you can set it to only push out, let's say like level 5, so it's not going to give you debugging information to your syslog server. It'll only give you anything severity level 5 and up, so like 5, 4, 3, 2, 1, 0. Do a little bit of reading of syslog if you don't really understand the levels of severity and messages. Alright, so that's syslog is now set up. Username and password, before I forget, we already said that VTY is going to log in local, but we don't have a local username and password. So I've already showed you how to do this. Username Cisco, we're going to give it a privilege level of 15 and set a secret password, which is going to be Cisco. Now the only thing left here, if I'm thinking correctly, is going to be to shut down all unused ports. So if we use our interface range command, Fast Ethernet 03 through 22 should all be unused. And we're just going to put in the command shutdown. And admin disable all those ports. If we do show IP interface brief, we'll see that all of those unused ports are now administratively down. Our ports we're going to use are up, and we need to shut down these two gig 1 and gig 2 ports. So interface range gig 01 through 2 shut down. Now if we do show run, we can see all the shit that we've already put on there. Oh, one more. For the syslog servers, we want to do a service timestamps, debug, and log. Oh, date time. My bad. So this will send the timestamps along with the syslog messages, which right now they're going to be wrong because we haven't set a clock, mainly because we can't use NTP on these switches, and I'm not going to worry about it. We can manually set the clock, but it's a pain in my ass, pain in your ass, and I don't really care. So we'll write that, do another show run, see our configurations, VLAN 10, we got our port security and all that running on Fast Ethernet 1 and 2. Go down, all of these are shut down besides our trunks here. Switch port mode trunk, no negotiate, no CDP enable, and the only VLAN allowed across them is VLAN 10. You can see our management interface here, interface VLAN 18 with its management IP, subnet mask, and the default gateway for all of this management traffic. Here's our logging info. Here's our access list for our VTY lines, which that's pretty much the only command we put in there other than login local. So this switch for our goals right now is done. Now, the beauty about having all of these access layer switches in roughly the same configuration is what we can do is highlight this entire show run, if it'll let me. Come on, keep up. Starting here, right click copy, and if we open up Notepad, we can paste all this in there and move on to access switch 2. And pretty much all we need to do is change the host name and the VLANs that it's going to be using. And we can just quick copy and paste this into switch 2, save us a shitload of time. So let's change the host name here to access 2. Our username and passwords are going to be the same. Our host ports are going to be on VLAN 11 and 12, so we just need to change these. And if you're wondering, that matches up here. Access 2, we've got VLAN 11 and VLAN 12 hanging off of that. We're going to change, what else? All of these same ports are going to be unused. We've got 23 and 24 as our trunk ports once again. But we're going to do allowed VLAN 11 through 12. It's going to be passing both of these VLANs. All the rest of the info is the same. Our management IP is going to change to 118 instead of 117. Default gateway will remain the same, as well as our logging server. So yeah, pretty much everything that we just did on access switch 1, we're going to do to access switch 2 in record fucking time. Paste. Bam. write that, do a show run, and we'll see that it took all of our commands. We got VLANs 11, VLAN 12 on our access, blah blah, 11 and 12 off of our trunks, interface VLAN, yeah. So that's the quick way. Set up multiple switches if they're in pretty much roughly the same configuration. Now I could go and do that same thing for access 3, 4, and 5, but you get the idea. I'm just going to end up doing that by myself on these last 3 switches. So that's pretty much setting up the access layer. It's one of the easier layers here. All we're concerned with is VLANs. Now I do realize if you're thinking ahead, we've got all these VoIPs here. We're going to need a voice VLAN, unless we're going to just run it over the access VLAN, but we're not. We will be coming in here later and adding a voice VLAN on these access switches, but that's going to come when we configure the call manager, because honestly I don't even know if I'm going to make it that far. But what we did, just to recap, configured all these. We have no CDP on our trunks, no negotiate on any of the ports really, except we don't have that on the ones that are shut down because we don't give a shit about those. We got the port security on the access ports and port fast on access ports, and all of our unused ports are shut down. So we've pretty much accomplished our goals in the access layer. We got trunking to the distribution layer and port fast, no negotiate, all that good stuff on our access ports. Now coming next, we will need to actually do DHCP to verify all this, but before that, just a little hint at the next video, we're going to set up the distribution layer here, which is where hot standby routing protocol is going to take over. And as you know, all of these VLANs are going to need their own default gateway, which are going to be interface VLANs off of our distribution layer switch. Now what we're going to do with HSRP is we're probably going to split this right down the middle here, and all of these VLANs will be using their default gateway off of this switch, and all of these will be using their default gateway off of this switch. And we're going to tune spanning tree to match. And if you don't know very much about spanning tree, it's very important, it's very fun, and we'll probably take a look at just a simple basic overview of what spanning tree does and how it works in Alex, but that gets really in depth and it's a main topic on a lot of the exams, so I recommend reading into it yourself. But pretty much we're just going to match spanning tree root bridges with our hot standby routing protocol active devices. But more on that in the next video. Hopefully this has done a little bit of something to or for you. I know a lot of it was review from one of the last videos, but it's coming. We're setting this network up. But thanks for watching.